Okay, so once you're on the PhET simulation, the one about the isotopes, your screen is gonna look something like this. Now, it may not have this checked, so if it's not, just click the little sign and it should bring this stuff up. So here's your element symbol. Remember, the top number is your mass number, the bottom number is your atomic number. Atomic number is also equal to the number of protons. You can see here that protons are orange, electrons are this blue, and then we're gonna add some neutrons in just a minute. So here's our abundance, which is what we've been talking about with an average atomic mass. Again, if that's not checked, you can always click that button and it'll bring it up, and it shows you that percent there that you're gonna write on the assignment that goes with this. So also, if this is here, that's fine, but you really need the atomic mass. You want that number there. And this number should be really, really close to what's on the periodic table, so we can kind of compare where those average atomic masses came from. So your first one is, the abundance is 99.9885% abundant, which means that this is the most common isotope of hydrogen. And the mass is 1, meaning it has 1 proton and no neutrons in it. But I can literally drag a neutron over, and now the mass is 2. And you can see here on the nuclear notation, the mass is 2, and the atomic number didn't change. The number of protons didn't change. We can't change that, because if we change the protons, it changes the element. But now that the mass is heavier, you can see that the percent abundance here went way down. It's 0.0115. So this hydrogen 2 isotope is a lot less common than the hydrogen 1 isotope, which is what it started out as. Okay, so you can drag the neutron over. Now, if you're unsure of if there's more than just 2 isotopes for an element, you can drag another neutron, and you can see this is hydrogen 3, so 1 proton and 2 neutrons, okay? And notice it just says trace. So you can write that down, you don't have to, but it just means that it's not really very stable. And you can see here, that's not my hand shaking on the video, it's because it is now unstable. It's basically too heavy for it to exist. This is really heavy hydrogen, so it's not super common. So then when you're ready to change the element for the next part of the assignment, you click over here in the top corner and you click on helium. So it shows you the new element. It's got the mass number of 4, and then the atomic number is 2. Remember, atomic number is how many protons there are. So those are the orange ones. And right now it's stable. It's got 2 protons and 2 neutrons, and the mass, or the average atomic mass, is 4.00260. I think on the periodic table that I linked in your stuff is 4.003. So it's just rounded a little different, but it's pretty much the same. So you can again see the abundance here for this helium isotope with a mass of 4. So 2 protons and 2 neutrons is 99.999% abundant, which means it's really, really, really common. So you can add a neutron like we did for the first one, and you can see that that is unstable. So notice that it's shaking. Okay, it says this isotope, this helium-5, doesn't actually exist. So we're gonna go ahead and take away that neutron, and we're gonna see if taking away a neutron does anything. So this is helium-3, so 2 protons and 1 neutron, and it does have some common abundance, so 0.0001% common. So not super common, but more common than helium-5. So make sure you're writing down that number and your percent abundance there on your assignment. Then you click on the next element, it's lithium. It's much bigger because now we have 3 protons, 1, 2, 3 of the orange ones, and 4 neutrons. Mass number is 7, you add those together, and then your atomic number is 3. That's based on the number of protons. So this isotope specifically has a percent abundance of 92.41. Okay, so the mass number is 7, it matches right here like it is. But there are other helium isotopes. So we can see if we drag one over and we do lithium-8, so we add an additional neutron, it says 0%. So that's probably not the way that we're gonna go. And if you look on the periodic table, the average atomic mass is a little bit less than 7 on your periodic table. So it probably means that there are some that are gonna be less than 7. So I'm gonna take away a neutron and make this be lithium-6, so a little bit lighter. And you can see that it has a percent abundance, or how common it is, of 7.59%. So that's a number that's definitely accounted for. So you want to make sure you write that down. Now, if you're unsure, if there's another one, we can take away another neutron, and it says 0%. So there's really only 2 isotopes for lithium. It's going to be 6 and 7. So one with 3 neutrons and one with 4 neutrons. Make sure you're writing down all of these percentages. You can choose the next element, beryllium, kind of the same process. It says 100%, so there probably aren't others. If you want to choose boron, same thing, 80.1% for this. If I take one away, it's 19.9. So just make sure you play with that and write down the numbers that you see. If you're unsure, keep adding them and it'll tell you if it's got an isotope or not, because some of them do not exist in nature.